In this video, we're going to solve applications involving unit analysis from Unit 2B. You'll need your scientific calculator. Again, for this, I have mine up off to the side. Decide which of the two given prices is the better deal and explain why. You can buy shampoo in a 5-ounce bottle for $3.39 divided by 5 ounces, or $11.89 for 14 ounces. Divide those out to get the price per ounce. So 3.39 divided by 5 is 0.68 dollars per ounce, 68 cents per ounce. 11.89 divided by 14 is $0.85 or 85 cents per ounce. The smaller size is the better buy here in price per ounce. 68 cents per ounce and 85 cents per ounce. The bigger is not always better. So decide which of the two given prices is the better deal and explain why. You can fill a 15-gallon tank of gas for $33.43 or buy gas for $2.20 per gallon. So let's go ahead and figure out what $33.43 divided by 15 is in dollars per gallon. That is $2.23, which is not as good as $2.20. So the better deal is to pay $2.20 per gallon, because this is $2.23 per gallon to fill the tank that way. Assume running consumes 100 food calories per mile. If you run 8-minute mile, what is your average power output in watts? So you need to know that a watt is a joule per second, and you need to know the conversion between food calories and watts. So give me just a second to tell you what that is. So it's 1 food calorie is equal to 4,184 joules. So now we have 100 food calories in 8 minutes times each food calorie 4,184 joules times 1 minute is 60 seconds. And a joule per second is the same thing as watts. So 100 times 4184, and then divide that by quantity of 8 times 60, which is 480, and I get 871.6, so round that to 872. The energy efficiency of electric vehicles is usually rated in terms of kilowatt hours of energy required to drive 100 miles. or kilowatt hours per 100 miles. An electric car is rated at 30 kilowatt hours per 100 miles. Is a vehicle rated at 29 kilowatt hours per 100 miles more or less efficient? It's more efficient, takes less energy to go that 100 miles. How much energy in kilowatt hours is required to drive this electric car? They're talking about the one that is rated at 30 kilowatt hours per 100 miles, 230 miles. So 230 miles times 100 miles down here, 30 kilowatt hours up here, and 2.3 times 30. So what that's going to come out to be 230 times 30 divided by 100 is going to be 69 kilowatt hours of energy. Assuming the electricity costs 16 cents per kilowatt hour, how much does it cost to drive this car 400 miles? So 400 times 30 kilowatt hours per 100 miles times 16 cents per kilowatt hour. Miles are going to go away. Kilowatt hours will go away. 100 goes into 400 four times. So 4 times 30 times 0.16 should cost me $19.20 to drive 400 miles. Block of wood has a volume of 250 cubic centimeters and weighs 0.260 kilograms. Kg over 250 cubic centimeters. I need that 1 kilogram is 1,000 grams here, so I can get grams per cubic centimeter. So that's going to be 260 grams over 250 cubic centimeters. 260 divided by 250 is going to give me 1.04 grams per cubic centimeter. That is heavier than, not heavier, but more dense than water. The density of water is 1. So anything that has a density greater than 1 here is going to sink. So block will sink since its density is greater than 1 gram per cubic centimeter. All right, that is it for this video, and we'll come back next time and we will talk about Unit 2B. So I'm sorry, we'll start talking about Unit 2C. See you for the next video.